The agenda which we're going to discuss today is introduction, BGP attributes, how it works, followed by configurations and Q&A. So if you have any questions, please note it down and we'll try to discuss at the end of the session. So let's start with the introduction. This is the hierarchy of protocols, and let's have a closer look on the dynamic routing due to time constraints. The dynamic routing is further classified into two: interior gateway protocol and exterior gateway protocol. The IGP is further classified into three types: distance vector, link state, and hybrid routing protocol, aka advanced distance vector routing protocol. On the other hand, we have EGP, which is classified into BGP. Just a few glimpses about BGP. It's also a predecessor. It's also a protocol once a predecessor of BGP, but it's now merely a category. The main difference between EGP and BGP is BGP is far more scalable and it supports CIDR. And BGP is further classified into two types: IBGP, which is interior border gateway protocol, and exterior border gateway protocol. And we're going to discuss it later in our session. So the introduction about BGP. Let me start in this way. BGP is the only exterior gateway protocol which are using it currently, and it's used to connect and communicate between different autonomous systems across the internet. Well, autonomous system is nothing but a set of networks under a single domain. And BGP is standardized by IETF, which is Internet Engineering Task Force. So if you want to run BGP in your organization, you should have a router which supports BGP and a public IP address and an autonomous system number from IANA. And of course, your ISP should support BGP too. IANA stands for Internet Assigned Numbering Authority, which has 5 regional internet registries, which are ARIN, RIPE, AFRINIC, LAPNIC, and APNIC. So if you want to get an autonomous system in India, you should go with APNIC, which stands for Asia Pacific Network Information Center. So far we have discussed about what is BGP and how to use BGP in our organization. Are we really required BGP in an organization? Any guesses, please? Are you really require BGP in an organization? Yes.
Putting networks on separating users.
Thank you for trying it. Let me explain in this way. Most of the traffic in an organization can be handled by the IGP itself. So BGP are mostly used under two scenarios where multiple connections exist to external layers such as an internet by a different service provider, or multiple connections exist to external layers such as an internet by a same service provider but is connected with a separate routing policy and central offices. Well, if put in simple, we can say it's BGP is used in a dual-homed network. Take for instance, in this case, router 1 is connected to the internet, which is connected to internet across two ISPs, ISP1 and ISP2. So if ISP1 fails, the traffic will automatically be routed across ISP2, and that's how it works redundancy. So let's go for the next slide. The facts about BGP. BGP uses TCP services, port number 179, for both to route the packets as well as for reliability. The third updates. Updates are triggered and incremental. Unlike in RIP, network updates are not periodically sent in BGP. Only when this network change happens, it is used to indicate its peers about the network changes. The next one. Metric is the biggest you have ever seen. Well, I can say it is a beauty of BGP because metrics is nothing but used to find the best path between source to destination while multiple paths exist. So take for instance in IGP world, we use complex metrics like bandwidth, delay or cost. In an instance for EHRP, there are 5 different metrics, K1 to K5, to find the best path. But in BGP, there are 14 different metrics, aka attributes, to find the best path. And as expected, we're going to have a closer look in our upcoming session. The last one is slowest routing protocol. Believe me or not, it's the slowest routing protocol in our universe. So any guesses? Again, why do we require a slowest routing protocol? Just give it a try, please. It can be interactive.
A lot of metrics are there.
Okay.
So for everything we need some time to converge.
Yeah.
So
that's exactly the answer. So let me explain in this way to the others too. Take for an instance, in IGP, we use routing protocols for faster convergence whenever there is a network failover happens. Say your organization might have 100 to 200 networks. So in BGP, it's connected to external AAs across the internet. So we might experience a network failover or flapping of interfaces every second. So if it's a faster convergence, if it has a faster convergence, it needs to find the alternative path every second, and it needs to alterate its routing table, which might be 1500,000 to 3100 routes. This again based on the capacity of the BGP router. So in order to avoid this from happening, they have designed purposely the slowest routing protocol. So let's go for the next slide. Peer messages and BGP tables. There are four types of messages: open, keep alive, update, and notification. So we can derive its purpose from the name itself. Let's start with the open one. Open is the one it starts or initiates the BGP process. Keep alive, it's like your heartbeat, ensuring that you're still alive and actively listening to the presentation. So are you guys listening? Okay, thank you. So the third one is update. So whenever this network changes happen, it's used to indicate its peers that something goes wrong, and it updates the messages to its peer. And the last one is notification. It's like a dead man walking. Something is bad, and it terminates or closes the session. The BGP table, it has three types again: neighbor, BGP, and routing table. Let me try to explain this in a scenario. Okay, can I get your name? So, okay, do you know the person to your right? Can I get your name, Mr. please? Venkatesh. Okay, so just assume Mr. Saravanan and Venkatesh are friends. Okay, so can I get your name, Mr. please? Nanabala. Your name? Any one person from the last? Your name? Sorry? Raghavan. Okay. So just assume Dhanapalan and Raghavan are also friends of Venkatesh. It's also be a friend of Saravanan. Okay. So this is what the neighbor table does. So it's Friday, right? Any movie released today? Did any movie released today? No one watches movie.
There were 6 movies released in our cafeteria.
Sir, any name of that movie? 11 movies. Alva. Okay. Okay, let's stick with Alva. Say, okay, Alva is released in a Rocky theater, and Mr. Saravanan wants to see this movie with his girlfriend. So are you married? Are you married? Or? Okay. So this Saravanan wants to see this movie with his girlfriend about the movie named Alva and Rocky theater. He needs to get his permission to his boss that he can't able to come to office today. So even though he has friends of Dhanapalan, Raghavan, and Saravanan, he only uses the best person to convey this message to his boss. Say for instance, he's calling his friend to Dhanapalan. Just say, Machi, that I want to watch a movie today. I can't able to come to office. Just say my boss that I'm feeling sick, and just say this particularly that I can't able to attend my phone too. So even though he has many friends, he only uses his best friend who is far more reliable and trustable to convey this message. And that's what the BGP table and the routing table does. It has all the routes to the destination. Even though it's has all the routes to the destination, it uses only the best path to communicate. So, am I clear so far? If you have any doubts, please note it down, and we'll try to discuss at the end of the session. Next is the peer state. Peer states are nothing but the steps which involve in forming relationship with its neighbor. So there are 6 types of states: idle, connect, active, open sent, open confirm, and established. Whenever you log into the router and enter the command, router BGP is so and so, it initiates the process and it goes to the idle state. From idle state, it goes to the connect state, where it tries to establish a TCP connection with its remote peer. As we discussed in the facts, it uses TCP services for both to route the packets as well as for reliability. In connect state, it uses TCP connection to establish its remote peer. If it's successful, let's go for the next state, which is open state. If it fails or unsuccessful, it goes for the next state, which is active. In active, it again tries to re-establish the connection with its remote peer. If it's successful, it goes for the next stage, which is open sent. If it's unsuccessful, it waits for the random connect retime to expire, and it waits for the random amount of time, and it reinitiates the process again. Just assume for this case, the TCP connection has been established successfully. Let's go for the open send stage, where it sends the open message to its remote peer and waits for the reply open message from its remote peer. So again, if it's successful, let's go for the next stage, which is open confirm, If it's unsuccessful, it's going for the random amount of time to reinitiate the process again. Just assume it got the reply keep alive message, reply open message from its remote peer, and it goes to open confirm state, where it tries to establish or send the keep alive message to its remote peer now. Again, if it's successful, it's go for the next stage, which is established state. If it's unsuccessful, it reinitiates the process again. So just assume we are at the established state. It got the open message, keep alive message. It sent the keep alive message and got the reply keep alive message from its remote peer. So it waits the update messages start to take place. It uses update messages to establish full routing information between each other. So for the first time, the routers established peer, it used to send the full routing information, and from the very next time, only the incremental updates will be taking place. So that's what peer state is all about. Next is the BGP attributes. Before going for the BGP attributes, I just want to take a quick glimpse about attributes. In IGP world, we use metrics to find the best path between source to destination, while multiple paths exist. In BGP world, we termed metric as path attributes. There are 14 different attributes, which is categorized into 6 different types, which are well-known, optional, mandatory, discretionary, transitive, and rumor. Well-known is nothing but it's supported by all the vendors, and optional is supported only with a few vendors. While mandatory, while it forms relationship with its peer, and in the update messages, these updates should be involved compulsory. That's what mandatory is. While the optional, it's not compulsory. And the last two, transitive and non-transitive. Non-transitive are like your secrets. If you share with your friends, it stays within. Well, transitive are like rumors. If you say to him, he will say to definitely to his friends too. That's what transitive is. And let's find about how BGP finds the best path. There are 14 different attributes, and due to time constraints, we're going to have a closer look at only some of the sessions today. Before going for this, just want to note about how attributes work. Attributes are like checklists. It just checks whether whether the condition matches. If it's not, it goes for the next state. It's appraisal time, right? So okay. All person may know some connectivity. Do you have what's it grade in data? Or your on-roll employee? E1. Really? Sorry? B1. B1. Okay. So assume both these persons are in the same company, same team. They are in the same process, and they're both trying for E2, which is not possible. Just for scenario's sake, we'll assume that. So when both people are trying to get E2, it goes to the management, and the management what it does is they compare both these persons' skills. They compare his performance. Again, both they perform equally good. They go for potential. If it's good, it's go for the next one, involvement, and so on other categories. So whenever there's a tiebreaker happens, it finds the best path. May say for Jovin gets the upper rank and it gets the best path. That's how attributes work. So this is the top 7 attributes, and first one is whether try to find whether the routes are accessible. The next one is weight, local preference, whether the routes are locally originated from the network, AS path, origin, and lowest multi-exit discriminator. I knew you doesn't understand this, so let's try to explain this in a scenario. Okay, you see, there are 3 autonomous systems here: AS 4500, AS 5500, and AS 6500. In AS 4500, there are 3 routers: R1, R2, and R3. And in AS 5500, we have R4, and AS 6500, we have R5. Just assume R1, R2, R3 are in the same autonomous system, so they form IBGP peers, and R4 and R5 are in different autonomous systems, so they form EBGP peers, which we are going to discuss later in our session now. So just for the sake, these are IGP peers and these are EBGP peers. Say AS 4500 is our Chennai branch, and AS 55 is our Pune branch, and AS 6500 is our Bangalore Ernakulam branch. We are at R1. The first step, whether it checks whether both the routes are accessible. The first one, ignore routes with an inaccessible nest of address. At R1, it tries to establish a connection with R4. It checks whether both the routes R2 and R3 are accessible. If it's accessible, let's go for the next attribute, which is weight. The thing about weight is a Cisco proprietary one. And the main thing about wait is that the updates which are sent in configured in R1 stays at R1. It doesn't go to the other routers. Say for instance, we need to prefer better routes across R2 than R3. We need to go to the router R1 under BGP command. We need to configure the weight to a higher weight. The default weight value is 0 and the higher value is a better one, which gives more preference. So just assume for the scenario's sake, both the routes are accessible and both has a default weight of 0. Let's go for the next one, which is local preference. Well, the main difference between weight and local preferences both works on nearly the same principle, influencing the outbound traffic, but weight is a Cisco proprietary one and it stays within the router. Well, local preference is not a Cisco proprietary, it's an international standard and it stays within the autonomous system. So assume again we need to prefer R3 via R2, better than R2. We need to go to the R3. Under R3 we need to configure the local preference to a default value, which has a default value of 100. The higher value is as a better attribute. So for instance, we need to prefer via R2 via R3. We can do it either two cases. We can go to R3 and increase the local preference value there, or we can go to R2 and we can decrease the value there. So in R3 we can increase the local preference which has a default value of 100. So if we increase the priority of R3 to 110, automatically R3 will be preferred over R2. If in R2, if not, we can go to R2, we can reduce the value below 100. If it's 90, it is 90 and it's a default value of 100. So R3 will be preferred more than R2. We can do it either two cases. So the next one is locally originated. So locally originated is nothing but whether it checks the destination is evolved from the same router or is from a different router. In this case, it's a different router, so it's got tied. Let's go for the next one, which is shortest AS path first. Well, in real time, most of the tiebreaker will be happened at the shortest AS path. Say for an instance, we need to connect from R1 to R4. R1 has 2 hops away, R2 and R4 to reach R4, and 3 hops away, R3, R5 and R4. So obviously the better route is R1, R2 and R4 will be given preferred and gives a better priority. So just assume there is no R5 in this scenario and both connected across 2 hops away to R4. Again it's got tied, which goes for the next one, which is origin. The origin is, okay, before explaining origin, just want to give a quick note about IGP. In IGP, we use a network command for both to advertise the routes and to form neighborships between our peers. But in BGP, there are two commands: network for advertising the routes and for neighborship to form pairs with its routers. So just assume, let's go for the R1. It checks the origin of the route. There are 3 types again in origin, which is IBGP, EBGP, and distribution. It just checks whether the route is redistributed via an IGP protocol, or it's from a network command, or it's from the HTTP gateway protocol. So distribution is preferred over internal and external. So the more the route, internal routes will be preferred more in origin. The last one is lowest multi-exit discriminator. The main difference between weight, local preference, and MED is local preference and travels or influences the outbound traffic, whereas the MED influences the inbound traffic towards CPO. It's also mostly configured at the end of the autonomous system. Say for an instance, we are configuring R3 MED. It influences its path and it might prefer the R1 to R3 as the best path than R2. Again, the lowest value is preferred. The default value of MED is 0. So let's talk about IBGP and EBGP. Routers which are configured under BGP, also known as speakers, and they form neighbor relationship, are termed as peers. There are 2 types of peers, which is IBGP and EBGP. If the routes or peers are from the same autonomous system, they form IBGP peers, and if they are from different autonomous systems, they form EBGP peers. Say for an instance, we have 3 autonomous systems here: AS100, AS200, and AS300. Router A and B form EBGP peers, and the router B, C, D, which are in AS200 or in the same autonomous system, they form IBGP peers. It's a main difference between IBGP. There's a basic difference about IBGP and EBGP. Let's go for the next slide, which is the configuration. In this scenario, we have taken three routers, router A, B, and C, and router A and B are in autonomous system of 100, and router C is in autonomous system of 900. So we look about the IBGP configuration between router A and B. We log into the router under the command router BGP. That is the autonomous system of 100. We have configured the 100 here. At go for the other command. We have configured the neighbor command at router A, which is 10.1.1.2, and the remote autonomous system is the same, this 100. And the next one, as I said earlier, we need to configure both the neighbor command and the network command for the routes to establish you. The next one is network command. As I use the 16-bit mask, I use the same mask here for network 10.1.0.0, which has a CIDR of /16. And the same thing repeats at router B. In router B, we use the same command router BGP under neighbor 10.1.1 at router B, and the same remote autonomous system as same as 100. And the network command is same for the 10.1.1.0, and it's a subnet mask of 255.255.0.0, which is a CIDR of /16. So after this command, just assume that router A and B form IBGP peers. Let's look for the next one, which is EBGP peers. It's between router B and router C. Router B is an autonomous system of 100, and router C is an autonomous system of AS900. In router B, we use a command router BGP under the same command as router B. We go for the next command is neighbor, which is this 172.16.1.2, which is a remote autonomous system of 900. The main difference between IBGP and EBGP command is the remote AS will differ. In IBGP, we use the same autonomous system, so the router knows that it's in the same autonomous system and it forms IBGP peers. In EBGP, the commands differ and it has a different autonomous system, 900, so it thinks that it's not in the same autonomous system, so they form EBGP peers. The same vice versa of router B here. In router B, we use the command router BGP 900 as router C is in AS 900. We go for the neighbor command, which is 172.16.1.1, which is a CIDR of /16, and let's go for the next one. We configure the network command to advertise a routes. So it has the IP address of 172.16, which is CIDR of /16. So these are the basic configurations of IBGP and EBGP. Let's discuss some of the verification commands. Before going, I'm at R2. I have taken the concepts of R2. It's in autonomous system. It's router B there, and it's autonomous system of 100. You see. So I'm just establishing command show IP BGP here. It has the version of 5, and it's a local router ID as 172.16.1.1, which is the same of its IP address here, 172.16.1.1, and it has two routes to reach it, 110.1.0.0, which is the IBGP, and 172.16, which is the EBGP peer. Can use the same network, and 170.16 is in AS900. You can notice there's a star symbol and a arrow symbol. This denotes that it has a best route, and while advertising, it uses these routes to form to advertise the routes and to form reader relationship. Which next one is show IP BGP summary. It again indicates the router identifier, which has the 170.16.1.1. R2 belongs to the local autonomous system of 100, and it has a table version of 5. And again, it has two routes. The first one is an IBGP peer, which is the same autonomous system. And second one is 170.16, which is an EBGP peer. In this, we can see it has a version of 4 autonomous system of. The first one is the same autonomous system of 100, and the second one is in 900. These are messages sent and received, means that it advertises or sends some messages between the routers. And it's up for nearly 30 minutes now. Next one is show IP BGP neighbors command. It's also a verification command and used for an IBGP peer. So router B, we are at router B, and we are going to see the IBGP neighbors now. It has the same IP address 10.1.1, belongs to the around system of AS100 and it's connected to an internal link, means it is an IBGP peer. And the rest of the comments are nearly same, just few information same between them. The one I need to focus on is local host and foreign host. The local host is 10.1.1.2, which is the IP address in router B, and it has the local port of 179, which is denotes that it uses the TCP port of 179. And the remote host is 10.1.1.1, 10.1.1.1, and it is a local foreign host of router A. Then next is a show IP BGP neighbors 172.16.1.2, just to denote about how the IBGP commands will be. It has IP address of 170.16.1.2, remote autonomous system of 900, and the main difference it is an external link, means it is an IBGP peer, internal and external. And the remaining thing are mostly the same. It has uses a port of 179.